Welcome student to Praveen Patil College of Diploma, Engineering and Technology. Our department is Humanity and Science. Our course Basic Mathematics course code 22103. Myself again Mrs. Smita Shekhar Kamble. Unit 1 chapter number 4 partial fraction. It is obviously our today's lecture topic. Again, resolve into partial fraction x square plus 4x plus 1, x minus 1, x plus 1 and x plus 3. These three are non-repeated factor. In numerator, x square plus 4x plus 1 is available. So we have to write x. These are unique factor and distinct factor. So we have to write x square plus 4x plus 1 upon x minus 1, x plus 1 and x plus 3 equal to capital A upon x minus 1 plus capital B upon x plus 1 plus capital C upon x plus 3. So LCM is x minus 1, x plus 1 and x plus 3. So multiply both sides by this term. So x minus 1 get cancelled. So we derive capital A into x plus 3 and x plus 1. X plus 1 get cancelled. So what is remaining? X minus 1 and x plus 3. So we have to x minus 1 and x plus 3. So here x minus 1 and x plus 3. Plus C. C denominator is what? X plus 3. So these will get cancelled. What is remaining? X minus 1, x plus 1. So it is available here. So put x equal to 1 in this above equation. 1 square is 1, 4 into 1, 4, 1 remain as the same. Capital A, 1 plus 1 plus 1 plus 3. But B is 0 and C is 0 because 1 minus 1 gives value 0, 0. So we derive the value of only A operator. 1 plus 1, 2, 1 plus 3, 4, 2 into 4, 8A. 1 plus 1, 2, 4 plus 2, 6. So 8 goes this side. So it is 3 upon 4. So capital A is equal to 3 upon 4. It is the value of A. Now we have to find the value of B. We must need to put x equal to minus 1. So 1 minus 4 plus 1. A and C now 0. B is equal to what? Then we have the value what? We have to put the which number? Minus 1. Minus 1, minus 1, minus 2, minus 1 plus 3, 2. So that's why minus 2, 2 plus 0. So 1 plus 1, 2, minus 4 it is minus 2. Minus 2 into 2, minus 4. 4 minus 4 goes this side. 2 upon 4. Minus minus get cancelled. 1 upon 2 is the answer. To find x equal C value, put x equal to minus 3 in this expression. So A and B 0, but C it is minus 3 minus 1, minus 3 plus 1, and instead of x we have to put the minus 3. So what is happen? Then it is what? X equal to minus 3, 9 minus 12 plus 1, 0, 0, C minus 4 minus 2. So minus 12 plus 1 minus 11 plus 9 minus 2. Minus 4 into minus 2, it is plus 8, C into 8. 8 goes this side, so minus 2 upon 8. So 2 1s are and 2 4s are. Answer is minus 1 upon 4. So this is the required partial fraction. We have x square plus 4x plus 1 upon x minus 1, x plus 1 and x plus 3. A value is 3 upon 4 upon x minus 1 plus B value is 1 upon 2 upon x plus 1 plus minus 1 upon 4 upon x plus 3. So we derive, if we take 1 upon 4, answer is 3 upon x minus 1 plus 2 upon x plus 1 and minus 1 upon x plus 3. This is also final answer. We write the, you get the derived whole marks, and if we take the common, you also derive the same marks. Now here what is given? X 1 upon x cube plus 3x square plus 2x. Now here x cube is there, here x term is there, here x is there. So we have to take the x common. So 1 upon x in bracket x square plus 3x plus 2. It is quadratic equation. It must have the real factor. Yes, 2 ones are 2. So final 2 ones are 2. So that's why final factors as 1 upon x, x plus 1 into x plus 2. Be careful, we have to must satisfy this polynomial have converted into quadratic form, and quadratic equation must have the real factors. That's why 1 upon x into x plus 1 into x plus 2 are the factors. So 1 upon x, x plus 1 into x plus 2. So capital A upon x plus capital B upon x plus 1 plus capital C upon x plus 2. So it is your LCM, multiply both sides. So A into x plus 1 into x plus 2 plus B into x plus 2 plus C into x plus 1 upon x, x plus 1, x plus 2. These will get cancelled. Easy trick is what? X is there. So x plus 1 into x plus 2 multiply by A. Okay. X plus 1 is there, then x into x plus 2 is there. If C we derive, x plus 2 is there, so we have to multiply x into x plus 1 into C. That is the easy trick. So 1 is equal to A in bracket x plus 1 x plus 2 plus B in bracket x into x plus 2 plus C x into x plus 1. So which are the true values for above value of x belongs to R? First factor is x. X equal to 0. We derive B and C is 0. B because x is 0 into anything 0, 0 into anything 0. So 0 plus 1, 1, 0 plus 2, 2, 1 into 2, A, and 1 remain as the same. So 2 goes this side, so it is 1 upon 2. Now we have to put what? X equal to minus 1. So we have to put the x equal to minus 1, A and C 0, B is minus 1 plus 1. Minus 1 into 1 minus B. Because minus 1 into 1 minus 1. So minus 1 into B minus B. 1 remain as the same. Minus 1 goes this side. So final answer is B equal to minus 1. Now we have to put x equal to minus 2 from equation 1. So obviously A and B are 0. C is minus 2 minus 1. 1 is remain there. So minus 2 minus 1 plus 2. 1 remain as the same. 2 goes this side. We derive the value of C is 1 upon 2. Hence, the required partial fraction are 1 upon x cube plus 3x square plus 2x is A is 1 upon 2 upon x, B is minus 1 upon x plus 1 plus C is 1 upon 2 x plus 2. If we take 1 upon 2 common, 1 upon x is remaining. Here 2 is multiplied, so minus 2 upon x plus 2, 1 plus 1 upon x plus 2. So we derive the final answer in this way. Next example is totally different from the x variable. How it is possible? Let us try. Resolve the following into partial fraction. E raised to x plus 1 is there. E raised to x plus 2, e raised to x plus 3. In a previous example, x term is there. So here e raised to x is there. So it is asked in summer 15. So we have to put e raised to x equal to 2. T. T is any parameter we have to put. So we derive what is the expression? T plus 1 upon t plus 2 into t plus 3. So we solve this in a partial fraction. Instead of x, there is t. So simplification, t plus 1 upon t plus 2 into t plus 3. So a upon t plus 2 plus b upon t plus 3. We have to take cross multiplication. So we derive t plus 1, these will get cancelled. Capital A into t plus 3 plus capital B into t plus 2. It is equation number 2. Now t plus 2 is equal to 0, that means t is equal to minus 2. So in this equation we have to put t is equal to minus 2. So minus 2 plus 1, a is minus 2 plus 3 is plus 1 but b is 0. Then minus 2 plus 1 minus 1, so a is minus 1. Now t plus 3 is equal to 0, means t is equal to minus 3. We have to put this equation number 2. So we derive what? Minus 3 plus 1, a into 0 plus b into minus 3 plus 2 is minus 1. Minus 3 plus 1 is minus 2. B into minus 1 is minus b. Minus 1 goes this side, it is minus 2 upon minus 1. Minus minus get cancelled. B is equal to 2. So we have to put the value of t, a and b in equation number 1. So t value is e raised to x plus 1 upon e raised to x plus 2 into e raised to x plus 3 is equal to minus 1 upon e raised to x plus 2 plus 2 upon e raised to x plus 3. So final answer we write first positive term 2 upon e raised to x plus 3 minus 1 upon e raised to x plus 2. So if e raised to x or sin x or tan x given, we have to put only t parameter and apply the rule of partial fraction for non-repeated method. Here, one more example in different pattern. 1 upon 1 minus x square is given. Solve it is into partial fraction. 1 upon 1 minus x square, we know that a square minus b square is a plus b and a minus b. So our a is 1, b is x. So a plus b into a minus b. So 1 plus x, 1 minus x. So we have to solve 1 upon 1 plus x, 1 minus x, a upon 1 plus x plus capital B upon 1 minus x. So we have to take the cross multiplication. So 1 is there, these cancel. So capital A into 1 minus x plus b into 1 plus x, which is true for all x belongs to R. Now 1 minus x equal to 0, 1 goes this side, so minus 1. So x equal to minus 1. So we have to put a x equal to minus 1. So b minus 1 plus 1 0. So we derive a 1 minus of minus 1 is plus 1. So 1 is equal to a in bracket 1 plus 1 plus 0. 1 plus 1 is 2, 2a into 1. 2 goes this side, so it is 1 upon 2. So a is equal to 1 upon 2. Now 1 minus x equal to 0. So x equal to minus plus 1. So we have to derive the value x equal to 1. So what is the answer? We have to put 1. So 1 minus 1 0. 0 into a is 0. So 1 remain as the same. 0 plus 1 plus 1 is 2. So 2 goes this side. So answer is 1 upon 2. So solving these, we have to derive a is 1 upon 2, b is 1 upon 2. So final answer 1 upon 1 minus x square is equal to 1 upon 2 upon 1 plus x plus 1 upon 2 upon 1 minus x. If we take 1 upon 2 common, then 1 upon 1 plus x plus 1 upon 1 minus x. So in this example, only x minus 1, x plus 1 is not given. Reverse way. First is constant is given, then the variable. We have to apply the same trick, a square minus b square, split up these and we derive, put the x equal to minus 1, x equal to 1. We derive the value of a 1 upon 2, b 1 upon 2. So final answer in a form of 1 upon 2. So be careful about these examples. Now we have to solve the 2x plus 3 x square x minus 1. Now here x square and x minus 1 is given. So it is repeated term. So 2x plus 3 upon x square x minus 1, a upon x plus b upon x square plus c upon x minus 1. LCM is x square x minus 1. So here y multiply x square into x minus 1. So 1x get cancelled. So a into x minus 1 plus b into, we have to cancel. So we derive x square whole get cancelled x minus 1 plus c into x minus 1 get cancelled x square. We have to put x equal to 0 first. Instead of 0, first we have to put x equal to 1. So we have to solve this example by this way. So 2 into 1, 3 plus 0 plus c is only derived. Because we have to put x equal to 1, these remaining 0. So we derive 5 is equal to c. Next step, x equal to 0 compulsory we have to put. Then x equal to 0 we have to put. That means the value of a is 0, c is 0, but b derived is minus 1. So b into minus 1, 0 plus 3, 3 is equal to minus b. So b is equal to minus 3. Now x equal to minus 1 is given. So because we put first is 1, then we have to compulsory put x equal to minus 1. B is equal to minus 3, C equal to 5 in above all equations. So we derive minus 2 plus 3, A into minus 1 minus 2 plus 3 into minus 2, 5 minus 1 square. So equating 1 plus 2A plus 6 plus 5, 1 is equal to 2A plus 11. 11 goes this side, so minus 10. A minus 10, so 2 divided by this, so A is equal to minus 5. So 2x plus 3 upon x square, x minus 1 minus 5 upon x plus minus 3 upon x square plus 5 upon x minus 1. So we have to write the positive term first, 5 upon x minus 1 minus 5 upon x minus 3 upon x square. So this is required partial fraction for repeated factor method. Be careful about all the steps I given and mentioned here. Be careful. A upon x, b upon x square, c upon x minus 1. We stop today's lecture.